Doing another example in chapter 11 at the request of a student who asked me the question via ask my instructor. This example is chapter 11, number 6. Let's try it. There's a couple small tricks in this problem. Nothing too complicated. And again, I appeal to you to avail yourself of the videos that I made that really explain the theory behind the confidence interval. Okay, so this thing we have a bunch of data. I think there are about 12 numbers. And the first thing is they ask you to look at the picture and try to decide if there's an outlier. Well, again, this can be done easily in StatCrunch. Open a StatCrunch. Okay. This time, one of the rare times you go to graph, make a histogram, and bar 1, nothing, nothing, nothing. Start at 0. I'm looking at the pictures to make that guess. They all start at 0, and they seem to have have a width of 5. And if you do that, you get this picture over here, which is, of course, the picture that we see in part B. So the answer to the question, of course, is part B, and clearly there's an outlier. This number here is really way out of line with the other numbers, and therefore might mess up the calculations. So the question now is, so the answer is there's an outlier. Find a 95% confidence interval for the true mean. Okay, so first let's do that, including the outlier, because they didn't tell you to drop it yet. So you go to Stat, T-stat, because we don't know the sample standard deviation. And again, the videos explain that. We have one sample, and we have the actual data. We want bar 1 to represent the data. This we don't need, this we don't need. We change this to I think a 90% confidence interval. And at this point, you simply say compute. And the numbers are somewhere between 31.38, copy, can't seem to drag it, and the upper end of this interval is 38.94. And let's test that out, and we're good. Now, if outliers are present, find the interval without the outliers. Well, again, there's one data point that seems to be the outlier. Let's go back to StatCrunch. This time, delete the outlier. Now, what's the outlier? Well, you can sort them, or you can just see it visually. The outlier is clearly the number 58. So let's delete it. See what happens if we do now 11 numbers. Stat. Still dealing with T-stats. One sample with data. Bar 1. Confidence interval of 90. Compute. And 1 second. Why does it? Oh, yes. We have it's the degrees of freedom is 1 less than the sample size. So now the answer is 32.38. Copy. Because that number that was weird increased the variation. So now we're going to have a much tighter confidence interval from 32 to 33, much narrower than before. Control C. Whoop, what did I do wrong? Control V. And the first one was, the lower limit was 32.38. Copy. Control V. So for now comes the interpretation. And to be honest, I got this wrong myself when I first looked at it. Okay, since there are no outliers, well, that's not true. There are outliers. The interval with the outliers contains the claimed mean of 36. Let's see them. This is the interval with the outliers. It's true. 36 is somewhere between 31 and 38. But the interval without the outlier lies entirely below the claimed mean. That's true. 36 is outside the interval. It's bigger than 33. Thus, there is not sufficient evidence to support the claim. We sort of have a contradiction, and we don't have enough evidence. We don't have clear-cut evidence that it's above 36. From this point of view, it's above 36. But if you include the data point, then it's really very often difficult to decide should I include it or not. Is it a real valuable number? So I'm going to say the answer is B. Final check. And we're done. Stop sharing. X out.